Now, in general, when we study periodic motion, we deal with waves. Waves, just like a sine wave that we already modeled, waves can be in water, can be in air, can be electromagnetic waves and light. These waves share some common properties. We already discussed the amplitude, the period, the displacement, the frequency. So what is a wave? That is the question. What is a wave? Imagine here, if you drop a water droplet or a stone on the surface of a pool of water, you will have waves, circular waves, spreading like this away from the center of the impact here. So one way to define a wave is to say that it is a motion of disturbance. Originally, there was a disturbance here at the impact point. This disturbance traveled away with time. So we may think of wave as a motion of a disturbance. Okay. Waves can be mechanical, like these waves, waves in water or waves in air for sound, or can be electromagnetic, as the case with light. So for mechanical waves, they require three conditions. You need a source for the disturbance, and then you need a medium. This is the medium that will transfer the disturbance, and you will need a physical connection or mechanism, which is in this case the simple harmonic motion. This is another type of waves. If you start with a rope like this, fixed at one end, and if you start shaking the other end up and down, you will create a pulse in the rope, and this pulse will travel along the length of the rope until it reaches the fixed end. Okay. So any element of the rope here will move up and down. Because of that, we call this wave transverse wave. Okay, the direction of motion for any element in the rope or in this slinky is perpendicular to the direction of propagation. The wave propagates horizontally, while the disturbance, the oscillation, is in the vertical direction. We call such a wave transverse wave. The waves in the ocean are a mixture of a transverse wave and longitudinal waves, superposition of both waves. They are complex waves. When we describe a wave, we have the velocity, we have the displacement, we have the amplitude, we have the period. Okay. Another way to create waves, consider this slinky. If you shake sideways, then the density here is more than the density here, so changes the density will also create a wave. This kind of wave is called longitudinal waves. Okay, So waves can be longitudinal. In this case, the disturbance is horizontal and the direction of propagation is horizontal. So for longitudinal waves, they will be parallel, while for transverse waves, the direction of disturbance will be going up and down, while the travel direction on the rope or string will be horizontal. Here, think of this rope connected to a blade, and the blade can move up and down, oscillates up and down. So it serves as a generator, a source to generate the waves. So you have now a stream of transverse waves starting from this blade. To describe these waves, you will need the amplitude, you will need the period, the frequency, and the wavelength. This distance here is called one wavelength. And we use the Greek letter lambda, this is the Greek letter lambda, to describe the wavelength. This is the amplitude, okay? And you know the period from this point to this point, this is one period. If you are talking about time, if you are talking length, this is one wavelength. So these are the parameters that we will need to describe a periodic motion or a wave phenomena. As we learned in physics 1, the velocity is delta x divided by delta t. For this kind of waves, delta x is lambda, and delta t is the period t. So the velocity equals lambda divided by t, or 1 over t is the frequency. The velocity is f multiplied by lambda. This is a nice formula to allow us to calculate the wavelength if we know the velocity and the frequency, or to calculate the frequency if we know the wavelength and the velocity.